Good afternoon, everyone. Welcome back to my YouTube channel. This is Catherine Atkunda, still taking in the tomato disease detection. This is the data set that I'm using in my tomato disease detection, and the link is there provided. Then I was able to come out with a notebook. That notebook involves the training the different data that I used, testing the data, validating the data, and everything that I used in there is presented in the link over there. So in this thing, I was able to make up heat maps, actually in the heat maps, as per my data set, as per the tomato disease detection. Remember, we are using images as our main thing, and images, heat maps are more convenient when it is numerical data. And for our sake, for my sake, it was image thing, so it couldn't relate out the heat maps. That's why I didn't come out with the heat maps. And as you can read through the slides, this is the definition of the heat maps. Then the correlation matrix, it's a table containing correlation coefficients between variables, with each cell representing the correlation between two variables. Like, its main aim is to summarize large data sets and visualize the different patterns in it. Then the box plot, it's a graph drawn to display the summary of the set of data values having properties like minimum, first quartile, medium, third quartile, and everything. Yeah, so as we go ahead, I imported the different modules that I needed to use in the work, like the TensorFlow. This TensorFlow has the different capabilities, like to deal with images. I imported it as TF, then I imported the OS, then I imported the data set, like I directed the data set, like TensorFlow.data.dataset. I didn't specify. Then I installed the OpenCV. This OpenCV is to open visualization, like because of the OpenCV, that's why I'm able to get up with this. So after doing that, I was able to get my data set up, and to show that the data set loaded, that's why I have this image on. And uh, the bunching, remember I imported NumPy, and NumPy deals more with arrays. So with the importance, with the use of NumPy, that's why I was able to come out with the different arrays, and I scaled my data. As you can see, the scaling shows you, like in the different batches it was able to come out with. Then in sprinting my data, what is the importance of sprinting data? I was sprinting my data into test, validation, and training, and I sprinted it in different percentages depending on the use I'm going to be using. So when we go, like the train size, like the train data set, I splitted it to 80%, approximately 80%. I gave it a much percentage because training takes a lot of data, and the validation is approximately 10%, equally the test size, because here validation and the test is printed it with less data because it can reuse the data. You can hold and use the data, but when you're training a model, you do not have to hold and reuse the data. So as you can see, the train size, the 250, like as I said, the train size is quite big than the validation size, the test size, and everything. So here, this is how the sprinting goes around, like train equals data, take train size, like the training data, take that size of data, the train size. Then the validation side, it should skip the train side and take the one, like that's the importance of data dot skip, that function of data dot skip is to show which one to measurize on. As you can see, it takes the test side, it takes the validation side for the different data sets. Then for the model fitting, I used a model fit function to do my model fitting, and then the training, like I logged in the directorate. Remember, I already loaded my data set as tomato. Then tensor callback, like using the keras, I was able to redirect my directorate, and then calling up the history and model.fit function, I was able to train my data, and that's the process of the data training. As you can see, the loss and the accuracy and the validation loss, I expect my loss to be reducing and my accuracy to be increasing, as you can pause in the video and visualize more. Then in compiling the data, I compiled my data, optimized my data using the Adam function. Like, what does compiling do? It compiles the different sections of data, and that's why I'm able to come out with that. the model does add this, and the COVID 2D is mainly used with the OpenCV, like to bring out the artwork of the images. And because of that, that's why I was able to the evaluation matrix after compiling the data, and I was able to come out to the performance spreads. This is the accuracy versus the validation loss, and you can see how it is varying. Similarly, when we go to the accuracy, you can see the accuracy is the one that is in the light when the very validation accuracy is slightly reducing, and this is a slight good improvement when you're dealing with models, most of the image models. Then evaluating my data. I evaluated my data using the TensorFlow matrix, the precision, the pre-code. As you can see the code below, this is bunching the different sizes. The X, Y is the way we have vertices, and the X and the Y side. The Y side contains the label, as you saw up the other side. I have the accuracies versus the loss, and yeah. So I was able to evaluate, and it was like up to that. Thank you for tuning in.